Alright guys, you're welcome to my next tutorial. Today we shall be looking at the concept of validity and satisfiability in the algorithm. Okay, now take for example, we have this expression represented with a symbol like F, not X or Y and X, and we are to check whether this expression is valid or whether this expression is satisfiable. How do we go about it? The definition of validity is an expression is valid when it evaluates to true for every possible assignment that we can have. For instance, if you look at this expression, we have in this expression two variables, x and y. And so we're going to look at all the possible combinations of x and y in this expression and check each one to see whether each one of them evaluates the expression to true. Although in this expression we have three literals, not x, y, and x, but we'll just consider the variables, which is x and y. So if we look at that, to check for validity, we look at every possible assignment. And here we have two variables, x and y. So the possible assignment that we can have is 0, 0, 0, 1, 1, 0, 1, 1. So we pick the first one, which is 0, 0, and go into the expression to check whether evaluating the expression with x and y equals to 0 will give us a true. So if we check here, this is 0, which is not 0 will give us 1, and this is 0, 0, 0, and 0 will give us 0. So 0 or 1 will give us 1, and our 1 means true and 0 means false. So we could get a 1 from this expression. So this gives us a 1. So this means this assignment satisfies our expression. So we can say that the expression is satisfiable using this assignment of x equals to 0 and y equals to 0. So likewise, we pick the second one to check. So x is 0 and y is 1. So when x is 0, so we have not 0 will give us 1, and 1 and 0 will give us 0. So 0 or 1 will give us 1. So this also gives us true. So this is also satisfiable. So this also satisfies. Then we check the third one, which is 1 and 0. So x is 1 and y is 0. So x is 1. So this is not 1 is going to give us 0. So and 1 and 0 and 1 is going to give us 0. So we have a 0 or 0. So this is going to give us 0. So because this evaluates to 0, it evaluates to false, then it means that this assignment does not satisfy the expression. And because this assignment does not satisfy the expression, it means that the expression is not valid. It means that it's not valid because we have gotten a particular assignment of the variables that does not evaluate the expression to true, and as a result of that, our expression is not valid. Right. So, and we can also try for the last one, which is 1, 1. So in 1, 1, that is not 1 will give us 0. 1 and 1 will give us 1. So 1 or 0 give us 1. So this is also satisfiable. So we can see that we have three assignments that gives satisfiability, but there's a particular assignment that does not give us satisfiability, which makes the expression not valid. So Now, if you look closely, you will see that in this expression we have uh, two variables, and that is why we have four combinations. That's why we have four combinations of four different possible assignments. So it means that if we have three variables, then as you can guess right, we're going to have 8 possible assignments. And if we increase it to n variables, if the number of variables is n, then you know that we have 2 raised to the power n possible assignment. Because of this 2 raised to the power n, it is in big O. This is what we refer to as exponential. So this is exponential. Because this is exponential, then we say that satisfiability problem is in a satisfiability problem, or SAT problem, is in NP, because to be able to get a satisfying assignment, the complexity in the worst case runs in big O of exponential. So we say this is MP. So it's in the time complexity of MP. But something is worth noting here, that when we have just two variables, we can easily enumerate the assignment and check for satisfiability. So we say that a variant of satisfiability problem, which is called 2SAT, where the 2 represents the number of variables, we say that 2SAT is in P, that is in polynomial. So this is in P, is in polynomial. Alright, so that is very important to note. Why 3, 4, and on SAT problems, they are in NP. So another important thing to look at is duality properties, that if I have an expression with the symbol F, is valid if and only if not F is unsatisfiable. So it means that if we take the expression and we negate it, for instance, if we take this expression that we have here and you negate this expression, then you have X, then you have and, then you have not Y, then you have or, then you have not X. If we try to enumerate and try all these possible assignments, and I want to give you that as an exercise to do, if you try that negation and you put in all these possible assignments, you will discover that it will be unsatisfiable. It will be unsatisfiable. So we say that not F is unsatisfiable if F is valid, and at the same time F is valid if not F is unsatisfiable. So thank you very much for listening. Do give us a comment and let us know your thought. If you benefited from this, you can give us a like, and if you have not, you can give us a dislike. All this will help us to be able to improve on a subsequent series. Thank you.